Hello, and welcome to this talk on DigoDoc and docs. My name is Mohamed Ernov, and I will present you our work done by OCaml Pro team and explain how we built our OCaml documentation hub using DigoDoc. As you all know, OCaml programming language is surrounded by a very rich ecosystem, which consists of many thousands of packages, which in turn include a lot of modules and libraries, starting from modelized algebraic data structure ending with web server skeletons. In such ecosystem, developers could find every kind of package that helps to build a solid, efficient, and large-scale projects. Package developers usually provide documentation for their package in order to use correctly its functionalities. Such documentation almost always consists of a set of static HTML pages. Each page lists types and functions inside the module for a given package. The set of HTML pages is generated automatically by existing tools called documentation tools like ODoc and OCamlDoc. Those tools read modules binary files and generate page that exposes commented interface for a given module. Despite all this, today's ecosystem is facing some problems. Firstly, documentation tools are quite limited by single binary file. For example, ODoc cannot find by itself locations of binary files referenced inside a specific module, which means that we should manually call ODoc for each module and for each dependency specify paths to its documentation that should be already generated. All that is almost impossible for a large number of packages. The second issue is the fact that there are multiple notions of projects in OCaml ecosystem. That implies that there are different ways to choose which notion will the documentation be based on. It's either the notion of libraries as a set of modules used by a OCaml compiler, either the notion of project with metadata used by Dune, either the notion of packages used by OPAM. Nowadays, there are tools in ecosystem considering just one notion, but not the others. And third, the biggest issue that is implied by two issues mentioned before is that there isn't a single place where a developer could find the documentation of all the packages, libraries, modules he might want to use. Instead, he should search it on multiple sites and platforms. Usually, documentation of a package resides on an official website of a maintainer company or, at the very least, on GitHub homepage. Sometimes, as you know, it could be really complicated to find what you want through all that decentralized system, especially for OCaml newcomers. That often makes them difficult to explore OCaml's ecosystem, and even sometimes that demotivates them. And finally, they give preference to other languages more suitable for ecosystem exploration, to other languages that unite every kind of information they may need in one single place. Afterwards, today we have a pleasure to introduce you DigoDoc, powerful tool that scans an OPAM switch and creates a graph associating modules to libraries and projects to packages, and then computes dependencies between all of them. Later, this graph is used for full and incremental generation of packages, modules, libraries, and projects documentation with ODoc. That helps to solve first two issues, in addition to the fact that it provides GitHub-like Source Explorer with syntax highlighting for OCaml files. Applying DigoDoc's functionalities on an OPAM switch with more than 2,100 packages gives us OCaml documentation hub, which for its part solves nicely third issue, and in the long term could be improved by covering all the packages in OPAM repository. The given site was entirely generated by DigoDoc, with all its indexation pages, allowing to find and to access easily to entry we want, only by its name. The site is actually active under the mentioned link. A large part of work done and of work that will be done for the site was inspired by counterparts from other languages such as Hackage for Haskell and Crates for Rust. And now let's move to the details. The first step we had to make was creation of switch, which is large enough to contain most of existing packages. OPAM is a package manager that uses dependency solvers for its package. Besides a built-in solver, OPAM also might communicate with external solvers through a CUDF format. In our case, we used external solver named SPQt. OPAM's user could customize solver with what we call preferences or criteria. In our case, we need to install as much as possible new packages while trying to install the most recent versions. And this is done by criteria specified in the slide. Additionally, we should specify some entry points for solver, and finally we obtain our switch with more than 2000 packages. All work done by Digodoc could be divided to 3 large stages. Each of them will be considered later. It should be noted that each stage depends on previous and couldn't be executed out of context. For example, docs generation needs computed data about every package and full graph of dependency, as well as indexation needs fully generated set of documentations. Throughout the execution, Digodoc deals with 4 main data structures. For each of them, he extracts all types of information we need during the first stage. For each, he generates documentation during the second stage, and for each, he creates a standalone index page. Switch exploring starts with scanning all the .changes files located in the same place. Every package has his own .changes, where we can find paths to all associated to him files, starting from compiled modules and libraries and ending with license and README files. Then for every package we handle all its associated files in order to extract all required information and in order to create corresponding data structure. OCaml binary files are firstly handled by OCaml obj.info that helps to get output that could subsequently be parsed. Parsing has a goal to initialize corresponding data structures and especially to get its hash code and hash of its dependencies. Later that will help to build graph of dependencies between the modules. Digodoc provides a library that parses meta files and extracts all type of information like description, version, meta dependencies, included metas, but also existing archives that represent either a library, either a module with the same name. All that information initialize meta entry at meta entry's data structure. The .mld and .md are separately saved and used afterwards during the doc generation. And the last stage of switch exploring consists to read information from OPAM file that helps to fill OPAM entry, which was initialized during the first stage. Subsequently, same file is used to compute dependencies between packages. Upon switch exploration, Digodoc has computed state of data structure and has information about belonging of those structures to the various packages. But despite all of that, this is still not enough to generate full documentation. So he proceeds to compute all type of dependencies, inclusions and associations between those data structures. Firstly, he computes dependencies between OPAM entries, basing on information extracted from OPAM files. Since packages names are unique, we could easily find the OPAM entry we want, knowing his name. For this purpose, Digodoc holds in his state global map of package, grouped by their name. Then he computes dependencies between meta entries by extracting desired information from meta files. Here he acts in the same way as with packages. Meta name is unique, and the corresponding meta entry could be get from a global map. Later he determines which module entries are included inside the library entry. At the moment of reading of library's binary file, CamelObj.info exposes all exported units. We could get module entry we want by comparing his name with unit1 in the same package. Then he associates meta entry to all its library entries by looking up archive fields inside meta file. Archive name corresponds to library name inside the same package, or inside the package of its meta dependency. And finally, he computes dependencies between all module entries. A module specify hash of all used external modules inside binary file read by CamelObj.info. Then corresponding entry could be found in global hash table, filled progressively during switch exploration. Like that, DigoDoc moves to the next documentation stage. At the very beginning, we generate documentation for module entry, because later they are referenced by other entries. So this is how it looks like. Since the algorithm strictly follows an order imposed by graph, all dependencies should be already generated. For other entries, documentation is generated by a quite different way. At first, all available information is transmitted to MLD page constructor, which builds a skeleton of future page, separates info by sections, and creates .mld file. That file is then compiled and transformed to HTML page. Also, DigoDoc generates separated pages for all .md and .mld files attached to entry. Additionally, DigoDoc generates Explorer for sources of append packages that helps to navigate easily inside source arborescence. To do that, firstly he gets package directory with opam source. Then he iterates over the directory and reads the file's content. During generation of HTML pages, Camel source files are parsed in order to generate highlighted page. Actually, we are working on expansion of the list of supported files. After documentation stage, DigoDoc passes to the last indexation stage that helps to create full cartography of the site and adds search functionalities. At the end of docs generation, DigoDoc sends requests to specific API server that iterate over the set of documentation pages and fills database of entries. Then he generates an index page for each type of entry, which uses JS of OCaml frontend. This frontend part is in turn communicate with another API server that deals with entry search in database. So that was a short overview to DigoDoc. Since this project has inexhaustible perspectives, we are still working on it. Right now we are working on improvement of Sources Explorer that will allow us to find out a type of a variable inside ML files and also to navigate between definitions. Also, we are working on extensions of search functionalities that grants possibility to customize the search and to find functions with specific name or specific type. And finally, in the long term, we want to document not only a precise version of a package imposed by switch, but also another versions. And on that note, I want to thank you for your attention.